In this video, we will see how to express the equilibrium constant in terms of pressure, because we have been using the concentration to express the equilibrium constant in terms of Kc or K or Keq. But for gaseous reactions, the partial pressure of a particular gas is proportional to its concentration. So we can also express the equilibrium constant in terms of partial pressure. So let's go ahead and see some examples of that. Consider the equation Ja plus Kb gives Lc plus Md. We can write the Kp expression for this reaction by putting Kp, and instead of putting bracket we are putting parenthesis, and we are putting a letter P, which stands for the partial pressure of equilibrium, and the unit of that pressure will be in atm. And P and C stands for the product, and L stands for the coefficient of that, and P again for the partial pressure, and the D the product, and M the coefficient. So note that again we are putting parenthesis, not the bracket, divided by, we have our reactant A, so Pa to the power J and Pb to the power K. That's how we are going to express in terms of partial pressure. And now to write the Kp expression for specific reaction, let us see these examples. Write the expression for K and Kp for the following processes, and we can see how is that different when writing Kc and Kp. So the first question is the decomposition of solid phosphorus pentachloride to liquid phosphorus trichloride and chlorine gas. So in this case we had to come up with the equation first, and then we had to balance it. So PCl5 is the phosphorus pentachloride, and which is solid. So that gives PCl3, which is again solid, right? Oh no, that is liquid. So that's going to be liquid, and we are going to get chlorine gas. And is it balanced? Yes, it is balanced. So that is the first step. So we have to write a balanced chemical equation, and then let us write the Kc, or we can say that is same as K or Keq. We can write that. We can see only for gas we can write. So this is liquid and this is solid, which will not appear in the equilibrium expression. So we will write chlorine in bracket, and we don't have any coefficient, so we will just leave it like that. How can we write for Kp is Kp equal, we will just write P, and you can write Cl2 to show that the product, again solid and liquid, will not show in the K expression, and that can be also written as PCl2 in parenthesis. Okay, and now second one, deep blue solid copper to sulfate pentahydrate is heated to drive off water vapor to form white solid copper to sulfate. So we will have copper sulfate pentahydrate. So this is copper sulfate, put a dot to show the pentasulfate. Penta means 5, pentahydrate, so 5H2O, which is in solid form, and this is blue in color, right? And then we can have copper sulfate solid, and we will have 5 water molecules, which is vapor, so gaseous phase. How can we write the K expression in this case? Equal concentration in bracket water to the power 5, because that's a coefficient, and we can write Kp by putting a P, H2O to the power 5. That can also be written as parenthesis PH2O, close the parenthesis, and to the power 5. Now let us see how Kp and Kc are related. They are not equal, so it is related through the formula Kp equal Kc RT to the power delta N. So what is each letter represent? Let us see. So R represent the gas constant in liter atmosphere per mole Kelvin unit. This is the unit, and we have to use the number 0.08206 or 0.0821 to round it. Okay, and then temperature should be in Kelvin scale, not in degree Celsius. and then Kp, you know, the K expression using pressure, and Kc expression using concentration. And now what is delta N stands for is the number of moles of gaseous product, that is important, gaseous product minus number of moles of gaseous reactant, only gaseous. And now let's go ahead and see some examples on this. Now let us see the example to calculate Kp. So in this question it is asked 2NoCl gives 2No plus Cl2 at 35 degrees Celsius. We have to calculate Kp using the given Kc value, which is 1.55 times 10 to the power negative 5. So what I will do, I'll just go ahead and plug it in the equation. The formula is Kp equal Kc R times T to the power delta N. So I can calculate delta N, number of moles of gaseous product. So I have 2 NO and 1 Cl2 as the coefficient here. So 2 plus 1 minus I have 2 in the reactant side. So 3 minus 2 equal 1. And then temperature I have to convert, that is 35 degrees Celsius plus 273, that will equal 308 Kelvin. And now I can plug it in the formula Kp equal 1.55 times 10 to the power negative 5, and then that multiplied by R value 0.821, temperature is 308 to the power 1, so that is not going to make difference. So 1.55 times 0.0821 times 308 times 10 to the power negative 5, that will equal, when you plug it in the calculator, you will get this answer. Let us see one more example. So in this question, the reaction of the formation of nitrosyl chloride was studied at 25 degrees Celsius. 2NO gas plus Cl2 gas gives 2NoCl gas. So the pressure at equilibrium given for each reactant and product, and then calculate the value of Kp for this reaction at 25 degrees Celsius. So what we have to do is, so the second question, Kp equal, I have to write the expression for that. So PNOCl to the power 2, because coefficient is 2 in the balanced equation, divided by PNO to the power 2 and PCl2, that equal, and now I can plug it in the values. NOCl, it is 1.2, we have to raise to the power 2, divided by, for NO it is given 5 times 10 to the power negative 2 to the power 2, and we have to multiply that one with the Cl2, which is 3 times 10 to the power negative 1. There is no coefficient for that, so I can leave it like that. So 1.2 times 1.2 on the numerator, divided by, in the denominator, 5 times 5, 10 to the power 2 times 2 is 4, so negative 4 times 3 times 10 to the power negative 1. So I'm going to solve on the numerator, it will be 1.44 divided by, in the denominator, 5 times 5 times 3 will be 75, and then 10 to the power negative 5. That equal 1.44 divided by 75. I'm taking that 10 to the power negative 5 from the denominator to the numerator, so that will be 10 to the power 5. When you simplify, you can see that 0.019 times 10 to the power 5, that equal, when you move the decimal to change it to the scientific notation, it will be 1.9 times 10 to the power 3. The second part of the question is, using the value of Kp obtained above in problem number 2, calculate the value of K, that means we have to find the value of Kc for the reaction. Same temperature, so there will not be any temperature change here. So 3, we can write the formula Kp equal Kc RT to the power delta N. So R equals 0.0821, and temperature I had to convert it into Kelvin, 25 plus 273, that equal 298 Kelvin, right? And then delta N is again number of moles of gaseous products minus number of moles of gaseous reactants. So that means I have 2 on the right side, that is the product, 2 as the coefficient, minus 3 on the left side, 2NO and 1Cl2. So that will give me -1, and then substitute. I'll go to the next slide. When you substitute, we can get Kp equal Kc. Into the formula we can substitute. So that is Kp is 1.9, that is we got that from the previous calculation, and Kc we have to find and substitute the value of R and then the temperature to the power -1. So then we can write 1.9 times 10 to the power 3 equal Kc. When you simplify that, 24.4658 to the power -1, and then we can divide on both sides to simplify. We can divide that 24.4658 to the power -1. This side also 24.4658 to the power -1. Right? Okay, then we can cancel the denominator from the right side and the numerator, and then I will have Kc equal 1.9. So we can cancel this one and this one. So 1.9 times 10 to the power 3 divided by 24.4658 to the power -1. So that equal 1.9 times 10 to the power 3 times 24, because it is -1. When we take it to the numerator, it will be +1. So we can just multiply those two numbers now. That will equal 46.485 times 10 to the power 3.